All right, so go to IXL.com and sign in. Please make sure that if you click on this top right icon right here, you can see your name. That's how you know you're signed in. Then you're going to click on learning. You're going to click at math. Mine looks a little bit different than yours, but the process is the same. Then you're going to go over to Algebra 1 and click on Algebra 1. And once you're in Algebra 1, you're going to go to DD, which is going to be on the far right. So AA, BB, DD, and I need you to do DD5, transformations of functions. Now, if you find that you're going to struggle with what I'm about to do in this video, then you need to go back and do DD1 first before you do DD5. In order to do DD5, you have to know the rules. So if you don't know the rules, you do need to go back to get those done. All right, so we're going to go ahead and get started. So here's the question, what the question is asking. So it's saying we're going to move translations 14 units up. So find g of x where g of x is translation 14 units up given f of x. So you're going to take f of x and then you're going to move it up. So you have to know what that means. All right, so what does up mean? If you're going up, which axis are you going? You're going over the y-axis, right? So if you're doing the y-axis, it's outside and it's what you think. So up would be plus 14 outside of the parentheses. And my pen is lagging a little bit, so please bear with me. Okay, so add 14 to the outside. So what is the outside? So remember, anything outside the parentheses or the parent function is what is outside. So what is the parent function here? Absolute value. So this right here is acting as a parenthesis. So we need to add 14 on the outside. So outside this is the parentheses. We're just going to add 14 to this number. So we have negative 10 plus 14. What is negative 10 plus 14? You're going to put that right up in a calculator. I'm just going to do it in my head, but put it in the calculator and then you're going to look for that exact answer. So everything else matches because the only thing we're changing is adding 14 on the outside. So negative 10 plus 14 is positive 4. So I should see something with positive 4 on the outside. There it is. Okay, and this is the process that we're going to keep repeating, but remember, you have to know what it's saying. All right, so now I have another one. I have a translation 13 units up. So what does that mean again? Going up is in the y-axis. That's going to be vertical. That means that I'm going to be outside again the parentheses, absolute value. So these are the parentheses right here. So this is the number that it's affecting outside. And what am I doing? Adding 13 to that number. So if I'm adding 13 to that number, again, put that in the calculator. So that's going to be negative 6 plus 13. I should have a 7 outside our parentheses. That's going to be this one. Everything else matches. All right, so now we're doing a translation 3 units left. Think about that real quick. Where is left, or how is left represented? Left is going this way. Which axis is that? That's x and what? Opposite, right? So opposite of whatever you think. So if I'm going this way on the number line, if this was a number line, and I'm going starting from 0 and I'm going 1, 2, 3, I would be subtracting 3, right? But it's going to be opposite of what I think because it's x and opposite because it's on the going left. So that's going to be really plus 3 on the inside. So identify your inside. So my absolute value right here is my inside. So this number right here, I'm going to add 3 to it. And then again, put that right in the calculator. So that's going to be negative 1 plus 3, and that's going to be 2. So this number right here is going to change from negative 1 to 2. Nothing else changes because the only thing I'm affecting is 3 units left. So I'm looking for plus 2 on the inside. That's the only one with plus 2 on the inside. All right, now we're going to do a reflection on the x-axis. Remember, a reflection is opposite no matter where it is. Because it's on the x, I would think that it should be flip over x, but it's really going to be flip over y because it's negative no matter where it is. So if it's flip over y, it's going to be on the outside. So the only thing that's going to change is on the outside, a negative times a negative will be a what? A positive, because all I'm doing is adding another negative here because that's what's going to represent a flip. So a negative and a negative is going to be a positive. So it'll be the exact same thing, only it'll be positive. So I'm looking for positive. This is the only one that's positive. Okay, so a lot of these, they're not going to try and trick you. They're just changing that one thing. Everything else is the same. You don't even have to pay that much attention to it. All right, reflection over the y. Again, so reflection over the y-axis is opposite no matter where it is. So you would think I would flip it over because it's on the y should be outside, but it's opposite, so it's really going to be inside. So then I'm multiplying everything on the inside by negative, so that's going to be, everything on the outside stays the same. So I should have -2 and a -10 outside, -2, -10, -2, negative. This is the only one with -2, -10, and then you multiply everything on the inside with the negative. All right, translation 7 units down. Okay, so 7 units down is which direction? It's going to be the y-axis, and it's going down. And because it's the y, it's regular. It's what you think. So if I represent going down, I'm going to be subtracting some number, which is 7. So I just need to subtract 7 on the outside only. So I come to the outside, subtract 7. Put that right up in the calculator. And I should have -2. This is the only one with a -2. Everything else stays the same because I'm only affecting the going up or down. All right, now it's going to change to a graph, and you need to know it from really all representations. This is a parent function for x squared, and something has happened to it. So now you have to write the rule, what has happened. So we started off with x squared, and if you remember when we did parent functions, x squared starts over here. So there would have been a dotted line like this. What happened to this dotted line to this solid line? I'm going to go right 5. So I'm going to go right, oops, sorry. I'm going to go right 5. So that's +5. But it's going to be opposite of what I think y, because it's x, right? So it's x and opposite. So instead of right 5 being +5, it's going to be -5. And then what am I going to do? I'm going to go down 1, 2, 3, 4, -4. And because y is what you think, it's going to stay like that. So I should have in the parentheses or in the absolute value -5 and outside -4. All right, so let's go ahead and do that. So now we're writing this function in this form. So what I'm going to do is just copy this form in here so I can write it just like that. Or I didn't copy and paste, and that's okay. So I'm just going to write it out. So this is x. All right, so I should have in the parentheses was left -5, and outside was down 1, 2, 3, 4. Don't forget the squared. All right, now I'm starting again with x squared. The parent graph was right here. And then I am doing what? Okay, so what am I doing after I do that? So let's draw it out for you so that you can have a visual. So x squared, you know, goes through 0, 0, etc. So how did I get from that to... How did I get from that to down here? So it starts right here. And then I go... I don't know why it's doing that. All right, so I start right here. Then I don't go left or right, but I just go down 10. All right, so if I'm going down 10, that's y and regular, right? So it's exactly what I think. So it's -10 on the outside. Okay, so I write everything else the same, just -10 on the outside. So if I start off with this, there should just be a -10 on the outside. That's all. So act like my parent graph is my parentheses. All right, so now I'm going to come to write the answer. It tells me write it in this form, so I'm going to do it this way. So there's x right there. That's my parent one, and then on the outside, I should have -10. All right, this is an absolute value function, and they tell you what the parent graph is. So here's the parent graph. These are the parentheses. Then what are you doing to it? So an absolute value, and honestly, if you don't remember the parent graphs, you can go ahead and type them in. Where is absolute value? Click ABC. Nope. Oh, right here. Absolute value of x. It's going to tell you what it looks like. So this is the original, right? And then now I need this original to flip over the x-axis. So talk about what is a flip over the x-axis. So remember, flips are opposite no matter where they are. So because I said flip over the x-axis, right? Go from this side down to this side. You would think it should be inside because inside is x. But negatives are opposite, so it's really outside. So again, you start with the parent function. So here's the parent function. Here's the parent function. All right, so then a flip should be right here. That will flip it over the x. And then did it move? No, it doesn't move, so that's it. That's all you have. And you can double check your work, actually, now that I'm here. You can double check your work in Desmos by typing it in Desmos. So let's go ahead and type it and see if it works. So I'm going to flip it right here, Does it flip over the x-axis? Yes, it does. And you can see it's a perfect match to what this one looks like. So that's what we're going to do. Boom, x, and then it should be a negative outside. All right, this is a parent graph of quadratic x squared. So you're starting with x squared, and then what happens? So actually, now that I've remembered we can do this in the calculator, I'm going to do it in the calculator to show you what it looks like. So there's the parent function for x squared. It's a quadratic that goes through 0, 0. What happened to that quadratic? It looks like it moved from 0, right 8, down 1. How do I represent right 8 and down 1? And now I'm going to just do it in the calculator so you can visually see it. Be nice if it was a little bit bigger. Hang on, there we go. Okay, so x squared is my parent graph. So I'm going to put the parentheses by my parent graph so that we're all set to go. All right, let's see if I can represent right 8. Okay, now remember, right is the x-axis. I'm moving over the x-axis, right? It's going to be opposite. So I would think it's plus 8, but it's really minus 8. And the good news is if you're doing this in the calculator and you try to do it plus 8, you can see it goes the wrong direction, right? So you can fix it. All right, so it's moved right 8. And then what do I need to do once it's here? I need to move it 1 down. So how do I do 1 down? 1 down's outside the parentheses, minus 1. And boom, look at that. This looks like a perfect match. So I'm just going to zoom in so you can see. There's the 8. There's the 1. So it moved to negative 8, 1. Then I'm just going to copy this into here. As a matter of fact, that's what I'm actually going to do now is just start doing it from Desmos just so that you can see. It won't let me copy and paste. I got to type it in. So minus 8 and minus 1. All right, so we're starting with a parent function x squared. So I'm going to start with x squared. I'm just going to have my parentheses ready. So your parentheses, your parent function is x squared. So now it's ready. All right, so how do I go from, let me click home. How do I go from this to here? It looks like all that happens is it goes down what? 7, right? How do I say down 7? Down 7 is the y-axis, so I should be outside and what I think. So down 7 is outside, and what I think down is negative 7. And let's make sure, so this ends up at 0, 7, and you can see that that's 0, 7. Now we're just typing it in, so x squared minus 7. All right. Okay, so now we're back to just writing it without a picture, and that's okay. So we're starting off with, all right, so find g of x when the translation is 1 right and 4 down. Okay, our original function is 6x. So we're going to start off with 6x. So this is our original function, boom. Now what we're going to do to this function is move it 1 right and 4 down. So you have to identify what's the parent function, just this x part. That's the parent function. So I'm going to take that and copy it here. All right, let's take it one at a time. 1 unit to the right. Okay, if I'm moving right, what axis am I going on? X. And x is opposite. So instead of me saying plus 1 because I'm going to the right, it's going to be opposite. So I'm going to say minus 1. So you can see, as soon as I did that, it moved 1 to the right. All right, now I need 4 units down, right? Which is the what? Y-axis. If it's a y-axis, it's y and regular. So it's going to be exactly what I think. So I'm going to go down 4 on the outside because it's outside. And that's it. Now we'll type that in here. I wonder if I can copy and paste. Oh, no, I cannot. So maybe not that. So... all right, so 6x, 6 parentheses x minus 1 minus 4. And I wonder if they want us to simplify, like multiply it in. Let me find out. Let's see, submit. They do want me to simplify it. So they do 6x minus 10. All right, so let me go ahead and, okay, so you do have to get into the parentheses. I'm going to show you, we're going to multiply this in. So this is going to be 6 times x is going to be 6x. And after I'm done multiplying this in, it should simplify. Then I've got 6 times negative 1, which is negative 6. And then I've got minus 4. And then now you see the blue line is a red line. We can combine these like terms. So I'm just going to copy them on the next page, on the next line, which is negative 10. All right, so this right here is going to be negative 10. And you can see it still matches. And there it is. So they do want you to simplify. They did not want you to leave it like this. They do want you to simplify. So just make sure you